So this video is going to be about acceleration, what it is, and how to calculate it. So acceleration is what happens when something changes a velocity, like it starts off not moving and it speeds up, or it starts off being very fast and it slows down. Here's an example of some things that have an acceleration. They start off not moving and they speed up like they're racing. The object with the highest acceleration is normally going to pass the finish line first. So in this case, the highest acceleration would be the yellow ball, then the blue cylinder, then the red thing, then the green thing. You're probably more familiar with acceleration from cars, and I would have put a picture of a car here, but common use, I can't just use any picture of a car. This was free. So before I talk about acceleration in depth, I want you to remember the basics of velocity, because it'll help you a lot, because they have similar frameworks. Basically, velocity tells you how many meters you move in 1 second. It's the rate of change of the position, how different your position is after a second. So a high velocity would mean that every second your position changed a lot, and a low velocity would mean that every second your position only changed by a little. So the word for the rate of change of velocity is acceleration. That's what it is. It's the rate of change for velocity, and it's a vector because velocity is a vector. It tells you how much the velocity will change in 1 second. Like the way that the velocity tells you how much your meters, or how many meters you move in a second, the acceleration tells you how much your velocity moves in a second. A high acceleration means that every second your velocity changes by a lot, like you're speeding up a lot or slowing down a lot, and a low acceleration means that every second your velocity would only change by a little bit. No acceleration would mean that your velocity is not changing at all. So the acceleration, in a nutshell, tells you how much bigger or smaller your velocity will be after 1 second. And in physics, we don't use the word deceleration when something's getting slower. We still call it an acceleration. There are pretty good reasons for this, but I'm not going to go into them right now. And if this doesn't confuse you, you could think of acceleration like the velocity of the velocity. If that's confusing you, don't worry about it. But if it's not, that's what it is. It's the same thing we do to get velocity applied to velocity. Some inception stuff going on here. So velocity is the change in position over the change in time. Acceleration is the change in velocity over the change in time. That's the formula, how much your velocity changes in a second. The units of acceleration you can figure out just by thinking about it. Acceleration tells you how much the velocity changes every second, right? So velocity is in meters per second. Let's say that every single second your velocity gets 1 meters per second faster. Well, then you could say that your acceleration is 1 meter per second, because every single second you are going 1 meter per second faster. And the units of acceleration are meters per second, and you can write that any of these three ways. The last one, it might not be obvious why meters per second squared is the same thing as meters per second, but just trust me, they're mathematically equivalent. And also right here, so acceleration is a vector, so I should have said that your acceleration would be positive 1 meters per second, but let's just assume that if I don't write a positive, it's there. So quick concept questions to see if you get it so far. Changed velocity by increasing 10 meters per second in 1 second. So the acceleration would be 10 meters per second, or meters per second squared. Next question. A car is going 20 meters per second on the road. Then 1 second later, it's going at 10. So it slowed down by 10. So to figure out the acceleration during this time, you say the change in velocity, well, it went down 10, so it was negative 10, over the change in time, which is 1 second. So if it slowed down 10 meters per second in a second, then the acceleration would be 10 meters per second squared. Finally, if a car is going at 20 meters per second on the road, and then it accelerates at 20 meters per second squared for 1 second, how fast is it going after? So the acceleration tells you how much the velocity changes, right? And if you're only dealing with 1 second, you don't have to do practically any math. So it's going at 20 meters per second, and in 1 second, it speeds up by 20 meters per second. So to figure out how fast it's going after that, you would say 20 plus 20 is 40. So we're almost done. Let's look at a motion with no acceleration. This is, imagine that you're taking a video of a motion, and every single second you write down how far it went. So at the beginning, it's at 0 meters, 0 seconds, 0 meters, but then 1 second later, it's at the 10 meter line, then 2 seconds, it's at the 20, and so on and so on. So because this is just 1 second at a time, it's really easy to figure out the velocity in meters per second. It's just however many meters it goes, right? So that goes 10 meters in a second, so it's 10 meters per second. And notice that every other second, it also goes 10 meters. It goes the same distance in the same time. So this velocity does not change. You have no acceleration. But if you do have acceleration, it'll look something like this. At the beginning, you go 10 meters in 1 second, and then after that, from 10 to 30, you go 20 meters in a second. And you would see a similar change in the velocity every second after that. So from 30 to 60, that's 30. From 60 to 10, that's 40. Or from 60 to 100, my bad. And then from 100 to 150, that's 50. So notice something about this velocity though. Every single second, the velocity changes by the same amount. It goes up by 10. So we would say that this motion has a constant acceleration. The acceleration was 10 the whole time. So if you have an acceleration of 10 meters per second, then that means for the first second, you're going to be going at 10. For the second second, you're going to be going at 20. And for the third, you're going to be going at 30. Basically, every single second, you will get faster. And then this is the very last thing to maybe give you an idea of what acceleration versus non-acceleration looks like in terms of motion. This thing is not accelerated, and this thing is. So in the first second, they both go 1 meter. But in the second second of the motion, this unaccelerated object moves the same amount, while the accelerated object moves more. It moves more in the second second than it did in the first. In the third second, this unaccelerated object moves the exact same amount that it moved the previous second and the one before that. But this one now, it goes even further than it did before. So it started off only going 1, and then it went 2 meters, and then it went 3 meters. So every second, it covers more distance. That is what it means to be an accelerated object. Hopefully this was helpful. Yeah.